which protocols run on TCP and UDP. Web feels instant, but under the hood, every click rides on either TCP or UDP, two very different transport choices that shape speed, reliability, and security. Today, a fast breakdown of which protocols run on which and why it matters. What TCP gives you. TCP is connection-oriented, a three-way handshake, order delivery, retransmissions, congestion control, and flow control. If you need reliability and sequence guarantees, you choose TCP. The trade-off is latency overhead and head-of-line blocking when packets are lost. HTTP over TCP. Classic HTTP 1.1 and HTTP/2 ride on TCP. The browser opens a TCP connection, sends a request, and expects an ordered response stream. Multiplexing in HTTP/2 still sits atop TCP, so one lost packet can stall others in the same connection. HTTPS equals HTTP plus TLS over. HTTPS layers TLS on top of TCP before HTTP messages flow. You get confidentiality, integrity, and server authentication. Then the reliable byte stream from TCP carries encrypted HTTP data. Most of the web still runs this stack. Email, SMTP over TCP. SMTP, the backbone of email transfer, uses TCP for store and full reliability between mail servers. When you absolutely need messages delivered in order and intact, TCP's guarantees make sense for queues and retries. Enter UDP's model. UDP is connectionless, no handshake, no built-in ordering, no retransmissions. You get minimal overhead, low latency, and application-level freedom to implement the reliability you actually need. If timeliness beats perfection, UDP shines. HTTP/3 via QUIC over UDP. Modern web performance flips the script. HTTP/3 runs over QUIC, and QUIC runs over UDP. QUIC brings TLS 1.3 built-in, zero RTT handshakes for stream reliability, and no head-of-line blocking across streams. Even when a packet drops, other streams keep flowing. This is how many sites achieve snappier loads on flaky networks. Mental model and examples. Choose TCP for protocols needing strict reliability and ordered streams. HTTP/1.1, HTTP/2, HTTPS, SMTP, IMAP, POP3, SSH, and most database wire protocols. Choose UDP when speed, multiplexing freedom, or custom reliability is key. QUIC for HTTP/3, many real-time games, live media, and telemetry. Then let the application decide which pieces to retransmit. Takeaways for builders. Reliability versus latency is a design dial, not a binary switch. HTTP/3 shows how we can have encryption and reliability features without inheriting TCP's head-of-line blocking. When designing services, start with user-visible goals, snappiness, loss tolerance, battery, then pick TCP, UDP, or QUIC accordingly.